Hello everyone and welcome to section 9.1.3. We'll be looking at telescoping series. So in this section we consider telescoping series. These are series where the terms cancel nicely. So here's example 9.1.5. Determine whether the series, and here it is, sum of 1 over n plus 1 converges. If it does, find its sum. All right, so let's start by just listing some of the partial sums. So if I write S1, I'm just going to plug in 1 into this, and I get 1 minus 1/2. If I do S2, that's A1 plus A2. For 1, you get 1 over 1, 1 over 2, and then you add to that what you get for n equals 2. So I'm going to get 1 over 2 minus 1 over 3. All right, if I do S3, that's going to be A1 plus A2 plus A3. That's 1 minus 1/2 plus 1/2 minus 1/3. And then I look at what happens when n equals 3. I have 1/3 minus 1/4. All right, terms cancel. I don't know if you could see it, but this one cancels with that one. And then for in S3, you have even more cancellations. And so every time it seems like you have the first term, well, the first part of the first term and the last part of the last term that stays. So let's try to see if that holds up for bigger n. So let's look. Let me write the terms in terms of k. That's going to help us write what Sn is. So there's a slight issue with the notation where n is playing both roles since we use an with an n and we use Sn with an n as well. All right, so I'm going to write the first 3 terms because that seemed to be enough to see a pattern of cancellations here. And then I'm going to write the same number of terms at the end. So an, the one right before is an minus 1, the right before is an minus 2. So I'm going to look at the first 3 terms and the last 3 terms in Sn and try to see if I can see the same type of cancellations. All right, so the first 3 terms we already have written right here, so I'm going to write them using that. And then I need the final 3 terms, so I need k equals n minus 2. So here I'm going to put in n minus 2 instead of k. I'm going to get 1 over n minus 2. And then when I put n minus 2 here, I get n minus 2 plus 1. I get n minus 1. All right, now I'm going to take k equals n minus 1. I'm going to have 1 over n minus 1. And then when I put n minus 1 here, it's going to be n minus 1 plus 1. It's going to be 1 over n. Let me make a bit of room to make sure I'm not too squished. And then for the last one, I'm going to plug in k equals n. I get 1 on n minus 1 on n plus 1. All right, what cancels? So 1/2 cancels with 1/2. 1/3 cancels with 1/3. 1/3. Sorry about that. All right, and then the 1/4 would cancel if I wrote the next term. So it won't be left over. It's just I can't write every single term because I don't know how many there are. Now in the back end, I have 1 over n that cancels with 1 over n. I have 1 over n minus 1 that cancels with 1 over n minus 1. And the same thing happens. That 1 over n minus 2, that would cancel with the previous term if I wrote it down. And so all I have left is this one and this 1 over n plus 1. So Sn is 1 minus 1 over n plus 1. And so if I want to know if the series converge, I need to look at the limit as n goes to positive infinity of Sn. That's going to be the limit as n goes to positive infinity of 1 minus 1 over n plus 1. That's 1 minus 1 over infinity, cheating brackets because I can't just plug in infinity, and I get 1. And so I get a number here when I take the limit of the partial sums. That means the series n equals 1 to positive infinity, 1 over n minus 1 over n plus 1 converges, and its sum is 1. You could also say it converges to 1. I like that too.